Let's look at 15e, which is hyperbolas. Now, up until this point, the only hyperbolas you've seen are rectangular hyperbolas. So the ones you would have seen last year, they look something like this. You'll have maybe an asymptote there, and that is a rectangular hyperbola, but we're going to do more hyperbolas this time. We'll see what they look like. So the locus definition, just stop the video and copy that out. You'll see that it's pretty much the same as for the last ones we did, the ellipses, except this time the distance from F1P and F2P, the distance, it must be the difference between the distances. So when it's difference, it's minus, and that is a constant. And I'm just going to put modulus signs around there because we know modulus says that means it's always positive. So the distance, the difference between the distances, and then just take whatever that number is, don't give it a direction. And the points F1 and F2 are called the foci, just like last time. So I'm just going to show you what it looks like. I'm going to do 2 points, F1 and F2, and I'm going to put a point P on them so that this distance from P to F2 and the distance here from P to F1, which I'll call distance 1, the difference between those two is constant. So that point just moves around here following that rule. So when we see it on a graph, it looks like this, where we have two asymptotes, but the asymptotes look like that, and the hyperbolas look like that, which gives us that shape there. Okay, so let's go and see what it might look like. It's the same as we did for the ellipses last time. So have a look. The only difference is here that it's difference. Last time that was a plus, now it's a minus, and here that was a plus, now it's a minus. So the centre of this first one here, 0, 0, centre of the second one, HK. So when you have one that has a centre 0, 0, these are our equations of the asymptotes, which is like I drew up here. But when we have centre HK, those asymptotes have been moved across H units and up K units. So that's the formula we use. So copy that screen of notes into yours and pause the video to do so, and I'll keep moving through. The examples that we're going to do, the first one's with a centre 0, 0, because we haven't moved across. So that's like the ellipses. And the asymptotes we said were at, well, what have we got? We've got A equals 3. Let's write that down. A is 3 and B is 4. So when we do B over AX, sorry, B is not 4, B is 2, of course, because it's the square root of 4. So B over AX, 2 over 3X is the first asymptote, and then minus 2 over 3X is the second asymptote. We can work out our y-intercept when x is 0, and if x is 0, this disappears, and we've got x squared on 9 equals 1, so x is plus or minus 3. Now we're going to say to find my x-intercept, y is 0. So I did that the wrong way around. Sorry, that's annoying, isn't it? When x is 0, we get minus y squared on 4 equals 1. So that tells me that minus y squared is 4. That's not going to work. That means that there's none, because there's no solution for that. You're never going to get an answer there where you've got, if you rearrange, you get y squared has to be a negative. The x-intercept when y is 0, so that's this one. That's when we're going to get x squared on 9 equals 1. So x squared is 9, x is plus or minus 3. So let's have a think of what this might look like. Oh, it's a bit squishy. The asymptotes, we've got 1, rise over run, 2 over 3x. So it goes 3 across, 2 up. And this will be the same. We've got our x-intercepts there. We've got 1 at minus 3, 0. And we've got one over here at 3, 0. This is y equals 2/3 x. And this is y equals minus 2/3 x. And there is our hyperbola. Of course, they get a bit harder when we get to the ones that have been moved across. That's going to be below. So what I'm going to do here with b, it's very similar to that first one. A is 2 because it goes with the x, and b is 3. It goes with the y. X-intercept when y equals 0. Well, that's when we're going to get the minus x squared on 4 equals 1. So that's not going to work, so there's none. And the y-intercept, x equals 0. So when we do x is 0, we're going to get y squared on 9 equals 1. So y squared equals 9, y equals plus or minus 3. And the asymptotes are going to be at 3 over 2x and minus 3 on 2x. Let's do it. Rise over run, 3 over 2, so it's going to be a little bit steeper. Label those. And draw our asymptote, our hyperbola, which has an intercept at 3 and at minus 3. So you'll see up in here, the order is important with the minus sign. If x goes first, it goes this way. If y goes first and the x is negative, it goes that way. Let's see what happens when we get to the next ones. And again, we'll have to use our calculator to solve because some of these get a bit tricky. So first of all, we know that the centre is at positive 1, minus 2. The asymptotes, well, we know what our equation is. And we know in this case that our a equals 1 and our b equals 1 because these are both over 1. So the asymptotes will be at y equals plus or minus x minus 1 minus 2. So if we get that, that's y equals x minus 1 minus 2, which is y equals x minus 3. The other one is at y equals minus x plus 1 minus 2. So y equals minus x minus 1. All right, so we'll draw those lines in a moment. We then find our y-intercept when x equals 0. And you just sub it in and rearrange, you get y equals minus 2. I'm not going to go through all that. You can do that on your own. And for the x-intercept, y equals 0. And you rearrange all that, and you get x equals 1 plus or minus square root 5. So then we think, what does this look like? I'm going to draw it here. A line of x minus 3, so minus 3 is there, it looks like that. And a line of minus x minus 1 looks like that. So that crosses at minus 1 and that crosses at minus 3. And then my centre is at 1 minus 2. That's this point here. And then we draw in our asymptotes. We draw in our hyperbola. And this point here is our positive intercept, 1 plus root 5. And this is our negative intercept, which is 1 minus root 5. And then we make sure that our asymptotes are labelled. And there we go. Now I've just made myself a bit of space to do D. That's why it looks a bit different. I'm going to do this by a different technique. So I'm going to show you with this one. I'm going to first of all just look at this, but without the minus 1 and the plus 2. And that way, if we do that one, that's a fairly easy one to do. And we learned how to do those. It's not dissimilar to the ones we did in the screen above here. So if I think of that one, just being a plain one there, I can work out that my intercepts are at plus and minus 2, and my asymptotes are these lines here. So the technique with this one is we can look and say, well, the one that goes with x is here, so A is 3. The one that goes with y is 4, so B is 2. And my centre is at the x value, minus 2, and the y value, minus 1. So that's how I've got this over here. And I think you can pick that up. And I made a spelling mistake. Enter, centre. I can spell centre. Hopefully you can. All right, so if I've got this original parabola without the left and right moving, what I'm going to do is I'm going to use that and I'm just going to translate it across. I know that my original xy now goes to the opposite of this, x minus 2, and the opposite of that, y plus 1. Okay, so the opposite to the sign in the middle. So if it was x plus 2, we know from what you've done last year that means you move it 2 to the left, and y minus 1 means you moved that 1 up. So that's basically what this bit down here is saying. So if I've got my hyperbola that I drew originally, I want to move that 2 to the left and 1 down. All right, let's do it. So the point that was at 0, 2, it goes 2 to the left. Sorry, I said 1 down, I meant 1 up. So it goes 2 to the left and 1 up, so it goes here. So it was at 0, 2, so now it goes to minus 2, 3. This one that was at 0, minus 2, it goes 2 to the left and 1 up, so it goes to minus 2, minus 1. That's a bit high. So all we've done is moved this point 2 that way, 1 up. We've moved this point 2 that way, 1 up. And the asymptotes, the same thing have happened. I've moved them 2 across and 1 up. So it did go through 0, 0. Now it's going to go 2 across and 1 up. So it's going to end up being there. And the other one, it's going to go 2 across, 1 up. And we know it's going to have that point there where it meets. And where it's going to meet is this number here, minus 2, 1. So then I put my the hyperbola, put it in here. And put this one in here. If I wanted to, I could then use CAS to solve, but if you look in the book example, they didn't actually find the intercepts here because they're a bit hard. The important things you have to have is the minus 2, 1, the minus 2, 3, the minus 2, minus 1, and then we need to label what these asymptotes were. So this one will be 2/3 x plus 7 on 3. And this will be y equals minus 2/3 x minus 1 on 3. And you can just get those by using the formula on this original equation. So go and have a go at 15E and see how you go with hyperbolas.